Hey everyone, to start today off, I'm going to go over a couple of things with you. If you want to skip forward to the homework because you feel like you already understand things from today, you are welcome to do that. But I strongly encourage you to watch this video because I'm going to go over vertex form again. Alright, so vertex form is just another way to write a quadratic equation. It's the same quadratic equation, it's just written as, oh my gosh, sorry about that, in a way that allows us to see the vertex more easily, right? So each form gives us something. Vertex form gives us the vertex, right? It shows us the vertex pretty easily. Factored form helps us to see the x-intercepts, also known as the zeros, because it is when y equals 0. And then last but not least, standard form helps us to see how wide or narrow it will be with that coefficient. You can also see that in factored and vertex form, but then standard form also really gives us the y-intercept quite easily with the constant. So these are the three types of forms and kind of what we use them for. So vertex form is written as y equals a times x minus h squared plus k. Again, if you go ahead and multiply this through, it's going to equal the same thing as standard form or factored form, but it is to show us that the vertex is h and k. Now remember that the equation has a negative in it, right? This negative right here is part of the equation. So the h, if it says minus 2, is actually going to be 2, right? So if we look at y equals, let's say 2 times x minus 3 squared plus 5, then here what is replacing h is 3, and what is replacing k is 5. So our vertex here is 3, 5. If I were to have the equation y equals 1/2 times x plus 2 squared minus 9, now what is replacing the h value is not just 2, but really this is x minus, because we need that in the equation, a negative 2. That's where we get that plus 2 from. And then the minus 9. This is outside, remember, so this is being subtracted from. It is not being multiplied. It is being added or subtracted here. And so then this will be negative 2, negative 9. That is our vertex. All right? So you're not doing any calculating here. You're looking at vertex form to determine what the vertex is. Okay, so let's go ahead and I'm going to erase this. And let's look at if I have a graph in which I can see that the vertex is, actually let me do a slightly better graph here. Let's say that I have a graph and I can see that the vertex here is 2, 1, right? I can start my equation and write my equation as y equals a, because we don't know what the coefficient is here, and x minus 2 squared plus 1. Using my vertex, putting in 2 and 1 into my vertex form. Now I can solve for a to know exactly what that is if I have another point. So let's say somebody said, oh, well, actually, the y-intercept is 0, 3. Now I have an x and a y value, then I can substitute into this equation to find a. Again, like you have pointed out, it is a lot of steps, but it's not impossible. You can do this. So 3 is going to be for y, 0 is going to be for x, and remember this is plus 1 on the outside, okay? It's adding 1. So 3 equals a times negative 2 squared. Negative 2 times a negative 2 is positive 2. So this would be times 4 plus 1. So this is 3 equals 4a plus 1. I'm going to subtract 1 from both sides. and then I get 2 equals 4a. Divide both sides by 4, and we get a equals 1/2. So now we know that this is actually a little bit wider of a graph. So we would say y equals 1/2, replacing a, times x minus 2 squared plus 1. So once you have that a, once you've done all that work to get a, you're just going back and rewriting the equation so that we can see what that equation is for the graph. All right, let's shift into your homework now. You did not have to do the Are You Ready for More, but I would encourage you to at least read over it and look at it and think about it, because I think it can be helpful to understanding it. Like, you can answer the question, what is the vertex of the graph? You can see that that is 3, comma, -4. And so now you can write that equation. Y equals a times x minus 3 minus 4. Don't forget that squared there. That's important. And then you can use 0, 14 to solve for a. So I would encourage you to try it because I think it's really good practice for you. Let's look at the homework problem. So it says select all the quadratic expressions in vertex form. So this one is in vertex form. For sure, we can see that. And this one is in vertex form. For sure, we can see that. This is in factored form. This is in factored form. This one is in both standard form and it is also in vertex form, because this one would be written as x times, correction, x plus 0 squared, right, minus 4. All right, and so this is 0, -4. This gives us the vertex there. Here are two equations. One defines the function m, and the other defines the function p. M of x equals x times x plus 6, and p of x equals x plus 3 squared minus 9. Show that the expressions are equivalent. So we're proving that these are equivalent. So this would be x squared plus 6x. Now this one I'm going to rewrite as x plus 3 times x plus 3 minus 9. Again, subtracting 9 from that. So the first thing I'm going to do from PEMDAS is my parentheses. So x squared plus 3x plus 3x plus 9 minus 9 is going to give me x squared plus 6x. 9 minus 9 is 0. So I have proven now that these are equivalent. So we get x squared plus 6x for both of them. It says, what is the vertex of the graph? So, of graph M. Well, remember that M and P are the same. So the vertex here would be -3, -9. It says, what are the x-intercepts of the graph of P? And so we would use this to find the x-intercepts because, again, these are equivalent. And so this would be 0, 0, because we have one factor here. And then x plus 6 equals 0 would mean that x equals -6. So this would be -6, 0. All right. It says, which equation is represented by the graph? So here our vertex is -3, -1. So I would do y equals x minus a -3 would be x plus 3 squared minus 1. So we want to look for one that matches that. Now notice too that we have a curve downward, so that also means that I have a coefficient that is negative. So that can help me eliminate a and b because I need to have a negative coefficient that causes this to flip. And so my best equation will be c, because here this -3 becomes a +3 when I put it into the equation, and the -1 tells me that I go down 1. For number 4, it says, write the coordinates of the vertex given this equation. So I'm going to model the first couple, but then I want you to try some on your own. So this one would be 3, 5. This one, because it's plus 7, would be minus a -7. So this is -7, 3. This one is very interesting, right? Because in order for us to think about this in vertex form, we are looking at it being x minus 4 squared, and so the vertex here would be the same as the x-intercepts, because x-intercepts would be here 4, 0, and there's only 1, right? So in between that would just be 4, which would give us 0. So 4, 0 is my vertex and my x-intercept here. All right, here, this is again the same as x plus 0 or x minus 0 squared minus 1, which means my vertex is 0, negative 1. All right, now this you're doing the same thing, you just have a coefficient, and that coefficient merely tells us how wide or how narrow the graph is. So you can still find your vertex the same way. So for E and F, I want you to find the vertex yourself. Number 5, for each function, write the coordinates of the vertex of its graph and tell whether the graph opens up or down. So again, we have a 4, negative 5. This is a positive coefficient, so it would open up. I'm just going to say it. You need to write it. Here we have, this is a negative times x plus 0 squared plus 5, so 0, 5. And that negative coefficient tells us that it opens down, so make sure to write that there. And then negative 1, negative 4. This would be minus a negative 1. And in this case, we have a positive coefficient, so that would be up. Again, make sure to write that here. All right, here's a graph that represents y equals x squared. Describe what would happen to the graph if the original equation were modified. So if I made this negative x, it would open downward, or you can say reflect over the x-axis. Reflect over x-axis. This next one, it would become skinnier, or we can say it would have vertical stretch. Because we're multiplying by 3, our values are going to increase faster, right? And so it would have vertical stretch. And then for this one, it would move up 6 units, or you could say translate up 6 units. So sketch this equation on the same coordinate plane. So let's sketch that equation. So we know that it would go down because it has a negative. It would be skinnier because of that negative 3. And it's moving up 6 points. So it would be up here, our vertex would be up here, and it would look like this. All right, number 7 is a review question. He's putting $2,000 in a savings account. He plans on putting the money in an account and leaving it there for 5 years. He can put the money in an account that pays 1% interest monthly, an account that pays 6% interest every 6 months, or an account that pays 12% interest annually. Which account will give him the most money? So you're going to write your equation. 2,000. Interest monthly for 5 years would be 60 times, right? 12 months times 5. So this would be 1.01 to the power of 60. The next one would be $2,000 times 1.06. Every 6 months, so that's twice a year. Twice a year for 5 years would be 10 times. And then lastly, 2,000 times 1.12, annually just 1 time. So for 5 times would be 5, or 5 years would be 5 times. So you calculate these in your calculator and see which one you think would end up giving you the most money. Is it 1% every month? 6% every 6 months, or 12% once a year. So you need to calculate those and then decide. Number 8, here are 4 graphs. Match each graph with a quadratic equation it represents. So we have our graphs, and then we have our equations down below, and we need to match them up. We have only one that is facing downward, open downward, and so that would have to be E. Because that's the only one with a negative coefficient. F has a x-intercept of -1 and -3, so we want to look back up and find where we have x-intercepts of -1 and -3. That is B. This one here would have a vertex of 0, -3, so that can help us to figure out which one that would be. It looks like that would likely be graph D, where we have 0, -3 as my vertex. And then here we have x-intercepts of 1, 3, so that helps me to match with graph B. So this is kind of combining everything that we've learned and talked about to match these graphs. So in this one, it looks like, first of all, that we are going up, right, and our x value is not by 1. We see a starting value of -2, so sometimes it's helpful to start with that. And then I want to figure out, how am I getting the rest of this? Well, what's tricky about this one here is that it's not increasing by values of 1. So as we go up 4, here we also increased 8. As we go up 6 here, we increased by 12. So what you might notice here then is this is doubling. So what I figured out here is we have -2, then plus 2x. So, or 2x minus 2. And you can try that out, see if that works. -3 times 2 is -6, minus 2 equals -8. That works. All right. 0 times 2 is 0, minus 2 is -2, right? So you can check to see that it works. But what I did here is I noted it's going up 4 and doubling, right? And then if it's going up 4 here, it's going up 8 here. If it's going up 6 here, it's going up 12 here. So that gives me that times 2 piece that I was missing. So this or this equation would work if we write it as f of x equals 2x minus 2. All right, park practice. This is the parabola. So this is the park practice that is related to vertex work that we did today. So here you can see our vertex here is 2, 1. It says the vertex of the parabola is 2 units right of the origin. We're going to go over 2, and 1 unit down from the origin. All right, so this is a select fill in. You need to get both of them correct. So just finding out what is the vertex first and then deciding where is it in relation to the origin. Remember, the origin is where x and y meet in the middle, 0, 0. It says this parabola is graphed in the coordinate plane. What is true about the vertex of the parabola? So in this case, our vertex is 2, 1 again, right? That's what it was up here. Yep, 2, 1. What is true? So it's 2 units to the left of the origin and 1 down. No. 2 units to the right and 1 up. Yes, that is true. Double check. Make sure you read all of them. 2 units up from the origin and 1 unit to the right. No. 2 units down and then 1 unit to the right. No. Just making sure you know which is your x value and which is your y value. Part B. How does the graph of the function f of x plus 3 compare to the graph of f of x? So if I'm adding 3 to x, what we would do is we would say f of x plus 3 equals, instead of x, I'm writing x plus 3. So x plus 3 minus 2 squared plus 1. That's where that graph is changing. So instead of x, again, you're just writing x plus 3. So we'd rewrite this as x plus 3 minus 2 is 1. So x plus 1 squared plus 1. Now my vertex is -1, 1. So the y value hasn't changed at all, but my x value has changed. So because the y value hasn't changed, the vertical shifts are not happening. It's not moving up and down. It's moving side to side. And so if it becomes -1 and it's going from +2, right? If it's helpful, draw a little graph here. Right, so my original vertex is here at 2, 1, and now my new vertex is -1, 1, so it's over here. So I've gone 1, 2, 3. I've shifted 3 units to the left. So I've shifted to the left 3 times, or translated left 3 times, all right? And again, when you see something where it's giving you a new f of x, just take whatever is in this parentheses and substitute that for wherever you have x. So I'm taking this f of x and putting it where x was, and then I can combine my like terms, and so I say a plus 1. We know a plus 1 in this parentheses means that the h value or the x value of my vertex is -1, and then again, the y value for my vertex remained +1. All right, your code word for today is, oh gosh, let's see. Your code word for today is microclimate. Microclimate. We've been looking at words that have micro in them on your word of the day. So micro Climate is your word of the day. If you need help, if you have questions, if you want to practice again, make sure that you watch the video, go back to the beginning. And I again recommend you practice the Are You Ready for More? It takes steps, but it's good for you to practice that. All right, happy homeworking and see you tomorrow.